and welcome to this part 2 of the video series showing the fundamental process of integrating large language models in intelligent tutoring systems, learning technologies, MOOCs, and other digital learning systems. First, for this instance, I am using a learning technology that is developed by the researchers at UMass Amherst, University of Massachusetts in Amherst. Using MathSpring, students from schools, from universities, they use this platform to practice and develop their math problem solving skills, and this system automatically adapts and intelligently uh, adapts according to the learner's math problem solving performance and makes decisions in order to help the learners succeed. If anybody is interested in knowing more, please look it up on Google Scholar. So let us begin. First, I created a sample user account for this demonstration and I will log in now. I have created this a couple of days ago. I'm going to just say get started. I'm going to go to my practice area. This is a demonstration screen. I'm going to go to next problem, quickly get through the initial steps. So this is the production math word problem that the learners see. If you are using any other technology, you can go to your main user instance. When I say instance, I'm talking about the index page, the HTML page, the page that is user facing, the learner facing. Within your system, you'll know what I'm talking about. And once you're on that page, you can follow the instructions that I'm going to share now. The instructions are all the same. So now that I'm on this page, I'm going to right click and go to inspect. So one other thing is I'm using this browser called Mozilla Firefox. If you're using Google Chrome or Safari or Arc or other browsers, you'll find a similar option. So just right click on your main user instance and then go to inspect. And once you go to inspect, you might see a screen like this, or you might see a welcome screen. If it's your first time on this page, it will give you a welcome message. Just close that screen and then you'll come to a page, an interface that looks like this with all these options on the top. By default, you will be in the inspector tab, and then you'll see console, debugger, network, and all the options. They may not be in the same order based on the browser, but in Firefox this is the situation. Once we are on this page, we don't really have to worry about any of this. We directly go to network. So click on the network tab on the top. So the network tab essentially shows us all the connection requests that my computer, which is my browser, which send all the connection requests it sent to the destination, and then all the information that has been passed back to me, and then I'm checking it from all sorts of media files that have been accessed. So that's why all is selected. Now 200 means that it's good to go. That means it's working. This is where the error codes also come from. Error 404 for not found, all that is also the same thing. 200 means it's working, and I know that because I can see the system in the back. For this purpose, you only see just 2 rows because we loaded this after we loaded the problem. So if I click and interact with any of these options here, I will see more rows automatically pop up because it's sending new connection requests to the server. So it just did one. It did one more because I'm clicking on it. Just for this demonstration, I'm going to go to a new problem to refresh this interface. Now that I'm on this new problem, this is a 6th grade geometry topic, area and surface area problem. This is based on Common Core standards. I don't know if this problem has previously appeared in the MCAS test, but it is likely it did. I may be wrong, but this is a human crafted, teacher generated math problem that has 3 hints which are also human crafted. So now that I'm on this page, I'm more interested in expanding the all 3 hints because I want to send as many connection requests and fill this up as much as possible. So that's one connection request, another hint, and I've seen all hints. So now essentially this problem has been completely viewed, which means that my new JSON file, which you can access by clicking on the HTML rows only. I'm going to click on this HTML one, and then a new column pops up, and then in this sub column I'm going to go to response. So when I tap on response, I see the JSON format, JSON file for my entire math problem. You can expand this to see the expanded version of the JSON. It also shows you there are 3 hints indicated in 3 flower brackets. It also shows you that something has a for row, and it shows you the Common Core standard. It shows you the area topic in Spanish also. This was from, I believe, another Spanish studies that we have done, most likely in Argentina or in Holyoke, Massachusetts. This is a practice problem. The problem ID, this is coming in from a HTML5 canvas, and this is the full Common Core category, and then you see where it is coming from. You can see the problem ID, and we can also see that it's a short answer type, and then other details. If you are already a MathSpring developer, you know, just by looking at this, you know what we are seeing per problem. So here I go and I say raw. When I say raw, this goes and it takes the shape of a this is the prettified JSON format. I would like to take it back to unprettified. I don't know, that's how I like the JSON files. I'm used to seeing them like that. And then I'm going to put the JSON file in a notes file that I'm going to paste right here. So essentially what we are seeing here is, I'm going to delete, we don't need that. This is the JSON file of this problem. And according to the video that I made previously, we are trying to create or we are trying to package the JSON file with a prompt. That is the trick here. So now that we have access to the JSON file, I have already crafted a prompt based on the CAST model and our previous research, which has been accepted to the International Conference of Artificial Intelligence in Education recently. I've used the CAST model by it's developed by I forgot the Jacobs and Fisher in their 2023 paper, based on the CAST model, which essentially talks about providing a criteria, the audience, this particulars, and further testing all done within a prompt, and that means, oh, and that brings us to this prompt which I have already made for this demonstration. So what we send in real time to the large language model is a combination of the prompt itself, prompt, and the JSON file. So this entire raw text is what gets sent to ChatGPT. Let's do a demonstration of the large language model in action. As you can see, I have many chats here and I've been testing with this for quite some time. I'm going to open up GPT-4 just for this purpose. I'm going to directly paste this. Again, all this is going to be done automatically in the backend. No learner will be able to craft a prompt like this. They will not ask for help, go to ChatGPT and ask for help. It is, as researchers, it is our duty to have this automated in the background. Only for demonstration purposes that I have extracted this and then manually pasting this in here to show the outcome, the output. Now again, I'm using GPT-4, which is a August 3rd version. The last version I played around just a couple of days ago was the July version. Now, since I've already crafted the hint in a way that it only produces 2 subheadings for the learner, these 2 subheadings will ultimately take the label of a prompt, a clickable prompt for the user to just click and then see this right away. I'll show that in just a minute. But essentially, when I look at the result generated text, you can see that it has already identified that the problem is from area and surface area clearly, because it is already present in the JSON file. And then I've asked it to create a label, how do I solve this problem? And I've also asked it to frame all this with a flesh readability index of easy to read, that's on the scale of easy to read. And so it has given me a small text blurb, which I believe needs to be reviewed further by a human tutor. But again, this is something that the learner will only see after seeing all 3 hints, manual hints. So this is a AI generated hint. And on top of that, the learner also sees a quick outline as to what needs to be done. Think of this as a TLDR of the generated output. So where do these go? Now that this is on an OpenAI chat interface, we can't let users go to this page. So where does this go? And for that purpose, I'm going to do this I'm going to repeat this again. This is a Canva file that we did a mock-up of in the previous video. You can go watch it. So the JSON file of this math problem we have extracted, we have sent it along with the prompt to the large language model, and it has created for us the output based on our criteria. And the text, instead of it showing here, how do I solve this problem, or AI generated hint, or glossary, or anything like that, more conversational, or translate this to Spanish, speak out loud in Spanish. We can have all sorts of multilingual abilities. They appear here. So essentially, when I go to the problem, the JSON has already been processed. The text has already been generated. It's just hiding underneath this icon right here. So when the user taps this, when the learner taps on it, it's going to then prompt and show all the available options based on its knowledge. Now, the one time if this has been processed by a large language model, we can repeat that same instructions over and over again for every single JSON file with the same prompt. If you look at the prompt, you are a K-12 math teacher with over 10 years of teaching experience to students from all backgrounds. I can't seem to see the full thing. This is a JSON of a math word problem that learners see on the front end. Your task is to develop, or task is to identify the topic and provide two specific components to the learner. One is a how do I solve this problem, and AI generated hint. Now this can be further simplified if more collaboration is happening with other teams, from other researchers from other departments, other backgrounds. We can make this even more solid by including as many variables as we would like. This was the all sorts of variables we have discussed in the first video. So that is essentially the one way to integrate large language models within MathSpring or any learning technology that you are using. And thanks for watching.